लिंक रे अछि ना हां अटेंडेंस लिंक रे अटेंडेंस लिंक हां मैडम जॉइन करो जॉइन करो आके टाइम दे रहा करो क्या आप अच्छी देगा हमारा जब सिलिकॉन
Yes. Ebe?
हां ठीक है
मतलब
कॉलर ईमेल आईडी ये अपन को तो से स्पीकर भी देखबे ना एटा देखबे एटा देख स्क्रीन आसबा ही नहीं स्क्रीन आसबा ही नहीं हां
या फिर स्क्रीनशॉट पूछी करता हूं मैं सब उनको
टाइम नहीं बताएगा फोन कर दो सर फोन करे सर के साउंड टेस्ट कर हेलो 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 ठीक है स्पीकर पे देखो गुड मॉर्निंग सर अच्छा एनआईटी वाला देना है हो गया और सिंस आगे कुछ ऐसा होने वाला पूरा टाइम है वो ऑसिंस जगह सिंस नहीं है हाँ से हम चाइनीज वाले लोग ना अपोंडा अलेक्सा मध्ये किती कोणता नाही मोस्ट आपण हॅलो मोटर
Hello.
Good morning, sir.
Good morning.
Yeah, that's the same for principal.
Is it audible?
Yes, sir, it is audible, sir.
Okay. Okay.
A hearty good morning to one and all, and a special welcome to all the participants to this valedictory session. The 4 days eFDP on application of remote sensing and GIS in civil engineering is on the verge of completion, and today is our last session. The resource person for this session is Professor Dr. Ratnakar Swain, Assistant Professor of National Institute of Technology, Rourkela, a renowned scholar with a sharp insight in modern technologies. His areas of interest are surface hydrology, flow and solute transport dynamics, soft computing in hydrology, remote sensing and GIS application in water resources, watershed development and management, and water quality assessment. His distinction as a teacher is unique with widespread fame. I specially welcome him and request him to enlighten the participants on the scheduled topic, monitoring of turbidity using remote sensing observations. Please, sir.
Thank you. Good morning, everyone. Is it audible to you all?
Yes, sir, it is audible, sir.
Okay. Good morning, all. Good morning, everyone. Let me share the screen.
Yes, sir.
The screen is visible or not?
Yes, sir, it is clearly visible.
Okay. Okay, I would like to thank the organizer and for choosing this interesting topic, that is the application of remote sensing in water source. If you know that remote sensing may be a very old topic, but it is always new, day by day, when new satellites come, when new technology come. So it is vast application, not only in this water source, but also in civil engineering, but also in all applications, all engineering applications. So this topic is very interesting topic, and if anyone choose to a career in this remote sensing, then it will surely she will get success. And the remote sensing, it has application in especially in water source. There is huge application, means flood mapping can be done, pollution source can be identified, snow melting study can be done, drought study can be done, surface water modeling can be done. So this topic which I am going to present, that is turbidity measurement. Turbidity, all we know that turbidity, it is the measure of intransparent of water. Using remote sensing technology, how we will measure the turbidity? So I will discuss about this remote sensing advantages and how we can measure the turbidity and how the performance of this measurement with reference to the observed data. This is I discussed that remote sensing application in water source, drought, the surface water dynamics, pollution sources, parameters we can study. So soil erosion we can study, water conservation monitoring like small conservations like ponds everywhere, that we can monitor. Flood disaster like flood mapping can be done. Sediment transport, landslide, that also can be studied. And main thing I missed here, that is remote sensing, that is climate change. Impact of climate change also can be studied using remote sensing. And the turbidity, we know that it is due to presence of this suspended materials like organic, inorganic materials, that it causes that it loses the transparency. That intransparent of water is called turbidity, physical. And the turbidity, you can see this figure, this river you can see. This turbidity is very low. It is blue, looking blue. It is gray here. So it is turbid, high turbid water. Muddy water, or you can say turbid water. This you can see the turbidity. Our turbidity changes when the color changes, that one turbidity changes from 10 NTU to 250 NTU. So when these changes occur, it affects the surface reflectance. The reflectance value changes, and that reflectance value is recorded by the satellite bands. And the direct concentration cannot be measured by the satellite bands. And that data, that reflectance data can be analyzed to get different concentration of turbidity or even other pollution parameters like TSS, chlorophyll, even heavy metals also can be studied to some extent. We know that river cleaning, it is a major challenge, and we need pollution sources in the river in real time. For an example, the Brahmani river, if you see, there is 37 industries. Means 30 industries, 7 mines. Central Pollution Control Board usually the measure the pollution at monthly basis now. Before it was quarterly basis. Now it is monthly basis. Okay, it is no doubt that it's most accurate because the sampling is done and then lab studies is carried out to get the accurate result. That is accurate. But the procedure is costly because sampling at the site, then you have to take to the laboratory, and it's not possible at finer spatio-temporal scale, finer spatial scale and finer temporal scale. Monthly data, monthly data, what we cannot use anything. We can say that whether it is polluted or not polluted, but we cannot get the source of pollution. So monthly data is not useful. For the pollution sources or the decision-making process, you have to we need data at finer spatial and temporal scale. In 320 kilometer, Brahmani 320 kilometer, 37 industries, and only few monitoring stations are there. So it is not suitable. This laboratory scale, although it is accurate, it's not suitable for river pollution monitoring. Same thing here, written here, laboratory testing, it is accurate, but it's cumbersome, high cost. Need expert people, and always at every point you cannot measure along the river because it's not accessible, and high floods it's totally not advisable to go to the site, and so it's not suitable for finer spatial-temporal application. And digital sensing is same as laboratory testing. Digital sensing is very costly. If you want to measure only turbidity or the chlorophyll or something, then okay, to 4-5 lakhs you can procure a digital sensor. But if you want you want to add more parameters, you need minimum all parameters. You need at least 30 or 40 lakhs to buy these digital sensors, which can measure all the parameters. And always it needs a calibration. And you cannot again you have to go to the site. Okay, it's laboratory testing is not required. Directly on field you can measure, but you have to go to the site. That is the problem. And visual interpretation, that is not considered. Yes, so this remote sensing is the latest technique which are used to monitor this pollution. It is a real-time water quality monitoring. In this study, I will show you how you can measure 30-meter and 1-day resolution. At 30-meter spatial, 1-day temporal resolution, you can measure the pollution. Means real time, you can see the source of this pollution. Accordingly, you can take the decision, and this study involve only freely available satellite images, so no cost involvement. These are the studies which earlier it has been taken, different satellites. Okay, All the satellites are not free. Some satellites are free, like Modi's Landsat is free. All the satellites are costly. Many satellites are costly. See, the authors, different authors have taken different satellites and studied in ocean, lake, river, everywhere. And they have not studied only turbidity, they have measured TSS, chlorophyll, many parameters they have studied. These are the also authors, the satellites they have used, the study areas. These are the satellites. So major working satellites means which are working now. Those are not working, it's are not included. These are the satellites. You can see the satellite sensors here. The country which launched, and the date when it's launched, and spatial resolution, temporal resolution, spectral resolution, number of spectral bands. Different satellites have different resolution, temporal and spatial. Temporal resolution means when again revisit period will come. At 16 day, last Landsat is 16 day, means if today you get one data, then after 16 days you will get another data. Again it will come back. And Moody's, you see, that is 1 day. Moody's 1 day resolution. 1 to 2 because it's some point, some location it is 2 days, but usually in all location it is 1 day. And spatial resolution means it is the pixel size. The pixel size Landsat is 30 meter. 30 meter pixel size in 30 square meter. So that value, the surface reflectance will not change in that 30 square pixel. It will change after that. In Aster satellites is 15 to 90. What is the range? In the Moody's it is 250 to 1000. It has different bands. Only the first two band is 250 spatial resolution. After that it is 1500 and 1000 meters. First two bands is 250 meters. That spectral ranges means different wavelengths are there. Why all different wavelengths? Because, and it is divided into different parts, and each part is controlled by each band. Let 36 bands, 0.62 to 14.38 spectral range of Moody's. You see, spectral range is 0.62 to 14.38. It has 36 spectral bands. Means this range is divided into 36 ranges, and each range is partitioned into each band. So everything we cannot measure at every wavelength. It depends upon the color. It depends especially the color which the reflection, different area, surface area, character of the surface area that changes the reflectance. So different wavelength have can reflect a different, can monitor different reflectance value. That's why the range is more. The satellites which have more bands, their satellite is good. Although spatial resolution, temporal resolution is good, that is also important. But number of spectral bands means that more means it can detect all reflectance value. Very vast reflectance range it can measure. Different satellites you can see from India, Cartosat, ResourceSat. These are the Landsat bands. See, Landsat 7, Landsat 8. Landsat 8 is the latest. Landsat 7 is just before 2012 it was used. After 13, Landsat 8 is used. Landsat 7 it is L1, L2, blue, green, red, 3 bands. That is next near infrared, short wave infrared, thermal infrared, short wave infrared. Landsat 8 it has again same L1, L2, L3, L4 different bands. It has different wavelength, different resolution. 30 meter resolution is 30 meter that pixel size bands. Different bands, different resolution. This is the Moody's. This is the resolution. You can see the characteristic of Moody's, different bands, different wavelength range, and the resolution. The first two band, first 1, 2, whether it is visible or not, I don't know. First 1 and 2, first band, second band, you see the wavelength range and the resolution, you see 250 meter. And this wavelength range the MODIS wavelength range of the first M1, M2. You can say that is M1, M2. First band, second band. As wavelength range, you can see, and the resolution is 250 meter. If you compare with Landsat, the same wavelength matches with L3 and L4 of Landsat. This we can say spectrally similar bands. This is called spectrally similar bands. L3, L4 of Landsat and M1, M2 of MODIS is similar, same, because its wavelength range is same. Wavelength range remains same. Here you see L3, L4 of Landsat 8, L3, L4 of Landsat 7. Wavelength range remains same with the MODIS M1, M2. That we can say spectrally similar bands. So in this study, why I mentioned this MODIS Landsat only, because I've used these two images, okay, to get the spectral reflectance and then concentration. This is the spectral reflectance curve. We know that pollutants affect the properties of water like pH, temperature, total stress, TSS, turbidity, everything. Okay, and this spectral reflectance, the reflectance is mostly influenced by the turbidity. If the water becomes more muddy, then reflectance value changes. And you see the different parameters are given. Different parameters have different reflectance value, have different wavelength. For clear water, it's turbidity, you can see. Clear water and turbidity, you can see. The wavelength range, you can see. So what is done here? The Landsat, because you know that MODIS has 250 meter spatial, but Landsat is 630 meter spatial. But MODIS 1 day temporal, Landsat 16 day temporal. So we have used a fusion algorithm that is called star FM algorithm. We have used blending, that is called blending algorithm or fusion algorithm. We used between MODIS and Landsat to get Landsat like surface reflectance, and that Landsat surface reflectance is compared with the turbidity observed value. We used different method to get the relationship like regression analysis, genetic algorithm. We used to get the relationship between the turbidity and the Landsat surface reflectance. So first we have to develop the relationship between regression and both genetic algorithm is used. And here star FM algorithm is used to blend this MODIS and Landsat band. Then water quality mapping is done. This is the star FM algorithm. This just I was talking about this MODIS image. You see the pixel 250 meter spatial 1 day temporal, which is high temporal but low spatial. Landsat, it is 30 meter 16 day, low temporal but high spatial. So use this algorithm or blending algorithm to get a synthetic Landsat like surface reflectance, which will give you 30 meter spatial 1 day temporal resolution. It is high and high temporal and high spatial. So how this method is used? In this method is very simple, because as you see, just you can understand here the MODIS at time t1, time t, time t2. You take three times, one time t1, time t, time t2. You know that MODIS image available every day. So at time t1 it is available, time t it is available, time t2 is available. But Landsat 16 day resolution. Okay, that is 16 day t1, t2. That 16 day gap is there. Okay, so Landsat image is available at t1, Landsat image is available at t2, but at time t it is not available. So our aim is to calculate, to estimate the Landsat at time t using this Landsat at time t1 or Landsat at time t2, and MODIS at this 3 time period, time t1, time t, time t. These are the known values. This time t2 is known values, LT1 it is known value. This is only unknown value. So what this algorithm says that the difference between the MODIS and Landsat surface reflectance at time t1, time t, and time t2 remains equal. So if we can get the difference here and this difference here, then we can get this also, this land satellite surface area time t. But there is a condition. To satisfy this equation, the condition is that the ideal condition should prevail. What is ideal condition? Ideal condition means the land cover should not change with respect to space and with respect to time. Means at time t1, okay, if it's water, at time t it should be water, at time 2 it should be water. Okay, so with respect to time and with respect to space, it should not be changed. If at 30 meter it is water, again at 250 meter means range, it is changing, means water to land, it is changing. So in that case, it is not applicable. Since in this study, we are taking at the middle of the river, at the center of the river, so where neither land cover changes with respect to time nor with respect to space. Always in Brahmani river at the center, there will be water in any time period if you choose. Okay. We are not taking the data at the side of the river, at the bank of the river, like in monitoring, digital sensing, or in other lab testing method. Usually the bank side they are taking water. Rarely they take from center. By boat they go there and take the sample, but in the bank they take usually. So that will not give you accurate results. See here, remote sensing we can take at the center of the river, okay, without visiting the site. So here ideal condition prevail, so this equation can be used. This is the overall methodology, whole methodology of the work, how MODI satellite is downloaded, how it is processed, and how satellite algorithm is used, and how data is collected from this data, how the relationship is developed here, GA based on linear and SPSS based linear regression model is adopted. And the 60% data is used for the calibration, and the 40% data is used for the validation of that formulation, and the best correlated model is used, and the estimated the turbidity concentration is estimated at a daily temporal and 1 kilometer spatial scale of the river. Then water quality mapping is done. Uncertainty and sensitivity analysis using Monte Carlo simulation is also carried out here. So this is the picture of the overall methodology. First model satellite is downloaded, reprojection is done, and sufficient number of surface reflection data you have to extract from the satellite image. Then coincident pixel means same point at MODIs and same point at Landsat at time t1, time 2 at the center of the river is usually if it's extracted. Okay. Then star algorithm is used to calculate the Landsat like surface reflectance. This is the Brahmani river. It is a CPSP report where it is mentioned all the data, means all the industries in 2005, major industries is mentioned. This is the latest industry location. All the industries I discussed about the 37 major industries. Here, this is the SPCB monitoring stations, Central Pollution Control Board monitoring stations. These are the monitoring stations. These are the industries. The red points, the red dot shows the monitoring station industries. 37 industries. Here it is mentioned all the industries, and location is here 37. SR Mining, JSPL, IKI, WL, Tisco plant, all 37 industries there. It is located here along the river. In 320 kilometers from here to here, it is 320. 320 means here from this junction. I am saying it's 320. It is 37 major industries, so highly polluted. Here it is a body article. It says if no one cares for the Brahmani river basin. Here the monitoring stations, 25 monitoring stations from that in that 320 kilometer range from here to here, 320 kilometer, 25 monitoring stations. Sunk, coil, Panpos, upstream, downstream, Rourkela downstream. So 25 monitoring stations are there. These SPCB monitoring stations, they take monthly data, and that observed data is used here to get the relationship with the surface reflectors. From where we will get the data? Here is pollution consumer that I told that Odisha State Pollution Control Board, Bhubaneswar. Moody's image, it is collected from USGS site. Landsat image is also collected from USGS site. This is the Brahmani River basin. It's Moody's and Landsat. It's just a comparison, a comparison of 13 December 2013 image. Landsat 8 image. This is Moody's image. The pixel value. It is the river. It is the river. Means you can see the pixels. The small pixels can be visible. These are the pixel size. These are the pixels. The small squares are the pixels. Here also pixels. It shows that many pixels. So if we take at the center of the river, so we can study the different. We can take, means the data can be used. We cannot use very thin or very narrow river. It is difficult, but the Brahmani river is very wide river. So we can take the data. It's not a problem. 1000 meter usually is 1000 meter is the it's wide. Width is 800 to 1000. If 250 meter at Moody's data we are taking 250 meter resolution, then it's not a problem. And Landsat is 30 meter. It's not a problem. It's valid. This TARFM algorithm is here. It is L1, L3, L4. That's TARFM algorithm we validate. Means we dated image we have taken 29th December 2013, 15th February 2014, 4th April 2014. Image, this is a calibration, validation. Both calibration, validation. L3, L4, sorry, only validation, sorry. L3 image, this is L4 image. L3 is L4, L3, L4. You see the range, it is here, performance evaluation is shown here. L3, L4, NAC value. You can see the NAC value, it is nearly 75%, 80%. L3, L4, it's nearly 75%. Maximum here it is, for this 15th February, it is 0.83 R square. 83 is the NAC of the L3 and 77 for the L4. It's 0.7 for L4 for R square. R square value of this 4th April is 75%, 70%. L3, L4. Suppose 0.76, 0.72 for L3, L4. Like that, IOA, index of agreement, RMSE value is also taken. So it shows that a satisfactory performance of this TARFM algorithm, means we can be used this algorithm to get daily data at 30 meters spatial scale. This is the sensitive analysis of Moody's and Landsat band specific relations, M1, M2. Different bands means how it's sensitive to M1. It is how it is sensitive to, sorry, how M1 is sensitive to L1, how M2 is sensitive to L2, how M1 is sensitive to L3, L4, M2 is sensitive to L3, L4, all. So here relative coefficient is given, sensitive coefficient. One at a parameter, that method is used, sensitive, one at a time parameter. That sensitive method is used here. This is the relationship that is developed between the turbidity and the Landsat L3, L4 bands. Using both regression analysis, nonlinear regression analysis, and genetic algorithm is used. Gene hunter genetic algorithm is used here. This is the modeling performance of turbidity. R square value, you can see that calibration it is 0.89, 0.9 in validation. NS value 88.66%, 89.74%. RMSE value 17.75%, 17.28% validation. IOA 96%, 97% validation. It is given mentioned in the main figure also. You can see. This is the calibration and the validation, estimated and observed values. You can see the turbidity. The lower turbidity values usually don't match exactly, but the higher turbidity value matches. Higher turbidity, more turbidity, more accurate result you will get. Very less turbidity, you will not get accurate result. Let's see, there is deviation from observed and estimated value. Deviation is there. Here, using this method, daily scale, at a daily scale, the water quality parameter is measured at Talcher station. Talcher station from 2014, June 2015, it is measured. And it is the spatial measurement. Spatial measurement. This is the this one was the temporal measurement from 2014 to 15, and this one is the spatial measurement along the river is from Swain confluence point, this confluence point to Janapur. This is Janapur point. From here to here, at every 1 kilometer, every 1 kilometer it is measured. January 2015 means average value is taken. January daily data is measured. Average value is taken of January. These are the observed values. These black dots are observed values. Okay, 0 to 320 kilometer it is measured. So this is the spatial measurement. At every 1 kilometer it is measured from the South Coil complex point to Janapur of January 2015. The uncertainty analysis is also carried out using Monte Carlo simulations. Here you can see the mean, turbidity, mean, median, minimum value, maximum value. We can take standard error, and uncertainty percentage 3.01%. It means 3.01% means if you go and measure one data at 10 NTU, it does not mean that it will be plus minus 10 NTU using this method. It means that if you get 100 numbers of data, the average of that data will be plus minus 3%. So it is the uncertainty of mean, not uncertainty of any particular data. Okay, so if you take 100 samples, 100 measurement, that average value varies with this in this range, 0 plus minus 3%. This is the histogram and base fit part of the turbidity in Monte Carlo analysis. Means this is the distribution curve it followed. That is the probability distribution curve. General Pareto distribution curve is followed, is used in the Monte Carlo simulation. Data, it depends upon the data how it is follows the PDF. If data it follows like this, then it is used in the equation, and random number is generated. 5 lakh random numbers is generated. Using that 5 lakh random numbers, using that equations, the turbidity is calculated, and the uncertainty, what I saw in the table in the previous, uncertainty is calculated. That is the Monte Carlo simulation analysis. At last, the mapping is carried out. Here I have shown actually the mapping is carried out for a whole river from that complex point to Janapur. Where here better clarity I am showing only the answer to Janapur. Here all the values, so which is the classified with less than 1 NTU, 1 to 5, more than 5. IS Indian standard, it is 5 to 10 it is dangerous. 5 to 10 is dangerous. 10 means it's not desirable, and above 10 it is totally not permissible. Above 10 NTU it is totally not permissible for drinking or for any special drinking. So more than 5 it's totally not useful. It is not desirable. So you can see full red means a whole river means it is means it shows that it's highly polluted. The river is highly polluted. So this study shows that this algorithm can be used to downscale the MODIs to get synthetic Landsat-like surface reflectors, and this map shows that the river is fully contaminated with turbidity. So it can be helpful to in managing the water decision. Okay, I mean water management decision and pollution assessment studies. This is one journal which is published based on this work. Also, it involved many other works, not only in this work. Other parameters have also taken. Different parameters, heavy metals have taken. I have taken different TSS have taken. Other parameters have taken. It is published in Journal of Environment Management. Thank you. Thank you all for your patience. Any question?
Participant, anybody want to ask the question, please raise your hand and unmute your microphone. Ambika Prasad Mahanti.
Hello. Ask Ambika Prasad Mahanti.
Ambika Prasad Mahanti, unmute your microphone.
Hello,
Yes.
Ratnakar sir, good morning. Myself, Ambika Prasad Mahanti speaking.
Yes. Yes.
Whether this remote sensing is applicable to know the other parameters besides the turbidity of any raw water in any river,
Yes.
other parameters like your dissolved oxygens, your other parameters, other quality parameters of any water.
Dissolved oxygen cannot be measured. Only the parameter which changes the surface reflectance, which changes the surface characteristic. It can.
So, no, just my question is, besides you have told about the turbidity, so the other
Yes.
parameters in
TSS.
water,
Yes.
whether it can be
TSS can
measured.
be measured. Iron can be measured. Iron content. If iron content, heavy iron content is there, let there is plant and from slurry water is coming, the muddy water is coming and it is a high iron content. That also changes the surface reflectance and you can compare with the observed iron content, observed iron concentration. Okay, then you can develop model and you can it can be measured.
So suppose
Yes,
turbidity in
suspended
the water.
solids. Total
Okay,
suspended. Yes.
total suspended solids.
Yes, chlorophyll also can be measured. Even oil spill is there. If oil spill is there in like in sea, water, that also can be measured.
Okay. Thank you, sir.
Welcome.
Sir, one participant in Sorrow asked a question: which tool you use to develop the SWAP algorithm?
Algorithm.
A participant Sorrow asked a question: which
Yes.
tool you use to develop the SWAP algorithm?
In this study, no tool is required. It is simple. You can write your algorithm in MATLAB also. That's not a problem. But it's in Excel also you can do. It's not does not require any tool because it's a linear equation. Only the time period T1, T2, T is there. So only we want the landslide like surface reflection at time T. If T1 data we have, T2 data we have, and the difference we can take. Because land cover is changing, so ideal condition is prevailing. So we can take that simple the difference in Excel we can do. No tool is required.
Another participant, Pooja Patnaik, asked a question: how to get the data of MODIS? Is it open?
How to?
How to get the data of MODIS?
MODIS, yes. MODIS image is available, freely available, just to download and you just process it in RGS, you can process it. In RGS, you can process it and you will get the data, all the reflectance value you will get in the and the table is there. You will get the table. It is easy. It's not a problem. Just data you download, image you download. The link I have given that Globis USGS, globis.usgs. Okay, if you go to that site, you will get the image, and not the band which exact band which you want, that you just download. Not all bands is required. No, actually, no. I just you can download. You can download everything. Okay, total satellite image you can download. Only you can use that 2 band, fast 2 band. Okay, you can download everything.
Participants who are watching in YouTube live streaming, if you have a doubt, you can put your question in the YouTube chat box so that I can communicate to sir. Participants who are watching in YouTube live streaming, if you have any doubt, you can put your question in chat box of the YouTube so that I can communicate to that question to sir.
Yes.
NK Narayan Swami,
Yes.
unmute your microphone. NK Narayan Swami. Rakesh Mohatra.
Yes, Rakesh.
Hello.
Hello.
I was, I mean, your work is wonderful and
Thank you, sir.
correlation has been established. I just wanted to understand that whether turbidity would be a very good parameter to monitor from the point of view of a polluted.
Yes. If you compare with other,
Which is also visible.
yes.
Visible.
Because I told in one slide that is actually it mostly influenced by this turbidity. The surface reflectance mostly influenced by the turbidity. Oil spill also you can measure.
Your methodology is wonderful.
Yes.
What I was just thinking, could there be a correlation? I mean, it may be going far, but could there be a correlation between the turbidity which is being measured and the other important parameters which are normally recommended for the
Yes.
monitoring?
Yes. That is TSS. You can get relationship with the TSS. Already the publication which I have shown.
Not a very important parameter for river pollution.
Yes.
It is a parameter, but not a very important parameter. You may have a correlation with the BOD or organic content or with the
Yes, it can be done.
or those type of things which have direct relevance to the river pollution.
Yes. That can be related with the turbidity indirectly.
Turbidity is a good one for eutrophication in the lake or some places which are far off or which people find it difficult in a difficult terrain or your Himalayan or something of this sort.
Yes.
For a city or industrial pollution in a river, I think it is a very good correlation, everything, but as a tool for measurement, I think utility is to be thought.
Yes.
Thank you.
Okay. Thank you. Welcome.
One question from Sindhu Mohanty. Other than GIS and remote sensing software, is there any other software for measurement of turbidity and other physical and chemical parameters of environmental engineering?
Using remote sensing?
Yes, sir.
No. There is no software or no method, means no software available till now which can measure directly the any pollutant concentration from remote sensing images. Only it will give you the surface reflectance, surface characteristic it will give you. After that, you can measure this turbidity or whatever the concentration. Like land use land LULC, land use land classification is done. From reflectance value, it is classified whether it is water or land or it is forest, like that. It is similar. So directly it will not give. There is no software.
One participant, KSP, asked a question in YouTube that the purpose of merging the M1, M2 and L1, L2 data was to get a better spatial and temporal resolution.
No, because it cannot be done. Because the theme is that the MODIS bands and the Landsat bands should be spectrally similar. Spectrally similar means I told that wavelength range should be same of MODIS and Landsat. L1, L2 wavelength range is different from the MODIS wavelength range. That's why L1, L2 cannot be linked with the M1, M2. Only L3, L4, which has similar spectral wavelength, that can be linked. That cannot be linked because its concept is wrong.
Hello.
Yes.
Hello.
Yes. Hello.
Do we have some UV sensors, ultraviolet sensors?
Yes.
I was just feeling that the organic content can be
Yes.
measured by UV sensors.
Yes.
I am not
Sensors are there.
knowing whether such a it is in use from the satellite.
Yes. Sensors are there, but sensors means digital sensing that I told. The digital sensors are there, but it's costly. Digital sensor very costly. You have to go to site, and you have to take means only laboratory testing is not.
Whether the satellites are carrying satellite sensors, I mean, are they doing the UV band measurements or something of that sort?
No. Satellites don't have any UV things. Only they depend upon the reflectance value.
Yes.
There is no UV link with the satellites. UV is with the digital sensors. Digital sensor you can go to site and you can measure.
Thank you.
Thank you. Welcome.
So one participant, Sudarshan SK, asked a question: up to what depth the turbidity can be measured? If surface is turbid and down below clear water, will it not give wrong result?
At what depth?
Up to what depth the turbidity can be measured? If surface is turbid and down below clear water, will it not give wrong result?
Yes, you'll get the result. How many days means you can measure at in time? If it is turbidity, okay, the satellite, when satellite takes the data, it depends at what time the satellites takes the data from that particular location. If during that period, that time it is turbid, then you can use that data. Otherwise, you cannot take. It depends on the time of travel of that satellite. In this study, the time of travel is taken into consideration. Usually here in the Brahmani River at 9 a.m. morning, the satellite takes the data. 8:30, exactly 8:30. It takes. So that's why it is used. Only the time it matters. The turbid changes. If you take turbidity value, you want to know concentration at 5 p.m. But sensor is coming on morning, then you cannot means turbidity changes over the time over the day. So that you cannot use.
Sir, a participant in YouTube live streaming, Sanjay Kumar Maji, asked a question: what are the causes of high concentrations of iron and chloride in groundwater?
Groundwater, aluminum chloride. Aluminum chloride is due to the aluminum chloride.
chloride.
Yes, it is due to the pollution. Due to the pollution, it is due to this. You can say this fertilizer, agriculture industry. From agriculture, it is incursion is there to the groundwater. So that causes pollution. Especially fertilizer is the main source of the chloride. Any chloride, nitrogen. What is saying that chloride that it is due to fertilizer.
Before the formal proclamation of the closure of the program, I take the privilege to thank Professor Dr. Ratnakar Swain sir for his erudition and command over the delivered topic. On behalf of the Department of Civil Engineering, Silicon Institute of Technology, Sambalpur, I am deeply thankful to you, sir. I also highly appreciate the active role of all the participants without whom the program would have remained halfway. At last, I request Professor Ashutosh Rath sir, who happens to be a vibrant, enthusiastic and agile faculty of Civil Engineering Department, to express the formal vote of thanks and simultaneously declare the closure of the program. Please, sir.
Good morning to all. Myself, Ashutosh Rath, Assistant Professor, the Department of Civil Engineering. On the behalf of our institute, Silicon Sambalpur, I take this opportunity to propose the vote of thanks to those who have directly or indirectly contributed to this eFDP. I would like to thank our esteemed speakers, Professor Dr. Prasant J from NIT Silchar, Professor Dr. Subhasis Datta, IIT Guwahati, Professor Dr. K.C. Tiwari, Delhi Technical University, Professor Dr. Ratnakar Swain from NIT Rourkela for making the excellent presentations and making this eFDP interesting and meaningful one. I would like to thank all the respected participants who have blessed us with their presence. I would like to thank our management, Director Sir, Professor Dr. P.K. Misra, our Dean, Professor Dr. Pinaki Das, Principal, Professor Dr. Ramprasad Panda, sir, for their moral support and guidance in organizing this eFDP. I am happy to express the vote of thanks to our staff members who have made this eFDP a grand success. Without their efforts, this eFDP would have not been possible. Once again, I thank everyone whose contribution has made this eFDP possible. Thank you very much. Have a nice day. Now, this eFDP is closed.